All right, guys, welcome to class. So in this session, we're going to be learning 10.3, and 10.3 is all about polar coordinates. All right, so we'll start by introducing it, then we'll talk about how the points look like. When we have points in polar coordinates, how does it look like? And then we'll go on to discuss the relationship between polar and Cartesian coordinates, and as well as we'll look at polar curves, talk about tangents, and then we'll just do some examples of curve sketching. All right, so introduction. Okay, so introduction. I'm going to write a few things. So, all right, so instead of describing the position of a point, in the plane by its coordinates. All right, so if you have a two-dimensional plane, okay, in X and Y axis, so instead of just talking about the points in the Cartesian plane, we can actually describe it by talking about its distance from the origin. So say do it by its distance from the origin. Okay, so if we don't use the word origin, we can use the word pole. Okay, so not just the distance from the origin, but also by the angle. Okay, so we can also use the angle between the positive x-axis okay, so and the ray joining the origin. Again, we can use the word pole if we don't want to use origin, and that point. Now, what does this mean, guys? Put a sketch right here. This is my x, right? This is my y. All right, this is my origin on my pole, 0. Now, so suppose that it's obtained at an angle. Let's say the angle is angle theta, right? Okay, so this point in space is what we refer to as P of x comma y. Okay, so but in terms of my, this guy is just r. In terms of r and theta, this guy is going to be r comma theta. Okay, where theta is the angle, then the r is the distance from the origin to the point we're talking about. Now, this theta is actually known as the directed angle, okay? The directed angle from the initial ray to have OP, all right? So this is O and this is P. All right, so what about this R? We call that R the distance from the origin to the point P. All right, so the x-axis here, we refer the x-axis as the polar axis, or what we call the initial ray, okay? And just as I mentioned, this guy is the origin, right? If you don't call it the origin, what else can you call it, guys? You can call it a pole. All right, so then how does points in polar coordinates, how do they look like? Or how can we talk about them? So points in polar coordinates. Okay, so it's usually given by r comma theta. Okay, sometimes you can have this guy. So I want to mention that these two guys, they lie They actually lie on the same line. Don't worry, guys. We're going to do some examples where we sketch and you see what's going on. So they lie on some line through the origin, but on opposite sides. Now, what's the difference between these two? Just the fact that one part is R is positive. Okay, so you have R here, and this guy is negative R. So the angle is still fixed. So the only difference is that they lie on opposite sides with respect to the origin. With respect to the origin. All right, so I need to let you guys know some equivalent definitions. When you have R, negative theta, polar coordinates, this guy is the same thing as R, theta plus pi. Okay, when you have negative R, theta, this is some kind of trigonometric equivalence, if I would say. Okay, so then when you have R, theta, this is R, theta plus 2k pi. Okay, so I gave you guys an example. So let me give you one more of this equivalence. If you have R, theta, an equivalent way to write it is this guy, 2k plus 1, then pi. This is pi. So suppose I have my polar axis, okay? This guy, suppose we subtend at an angle. Have a short angle here. I suppose we have a bigger guy here. Okay, this should be a perfectly straight line. So let me make this better, guys. So suppose we have something like this guy. So this point is my origin. So we have subtended at an angle. Okay, so this is angle theta. This is a point. The distance between this guy, the origin, and this point is called R, right? Now take a look at this part. Suppose I have the same similar points here. The distance between this guy and this guy is going to be negative R. It's on the opposite side. Okay. Now, how do I refer to this point? This is R, theta. What about this point? This is negative R, theta. Okay, so there are a few things to take note of. I'm going to tell you guys a couple of things. So note, first thing to note is that this angle, when this angle is positive, it is counterclockwise. Okay, counterclockwise means the opposite way the clock works. Okay, so we know the clock goes this way. Counterclockwise is this opposite direction. So this guy is clockwise. This guy is counterclockwise. Okay, counterclockwise from where? From the polar axis. Second thing, all right, so you remember, guys, we do a little bit of learning the theories and then we'll go into some few examples. So we're still just on learning the theories, kind of building a foundation to which we can discuss the examples to come. Okay. Let me call both of them number 1. So let me call number 2. Is to say that the angle associated with a given point is not unique. Okay. Now, why is it not unique? For the reason we have above. Okay, so I gave you guys equivalence. Negative theta could be replaced by theta plus pi. Theta itself could be theta plus pi. Okay, so some sort of, think about trigonometric, sine of x could equal sine of x plus something, such kind of thing, like cosine of 60, those kind of equivalents. When does sine and cosine equal themselves? I mean, that's a just, pretty basic example. So while the points in the plane, well, what do we mean by plane here? We'll talk about the x and y. Has just one pair of Cartesian coordinates. Okay, the same point. In terms of polar coordinates, it will have infinitely many pairs. Okay, so this is just a little bit of learning the theories, just as I said. Okay. A little bit of learning the theories. Now, let's go to example, okay? Now, suppose I want to actually, in polar coordinates, I just want to draw the points 2, 0, okay? So remember, it is r, theta. This r is just a distance from the origin. This guy is the angle, okay? So over here, my r is 2, okay? So I'm gonna have something like this. Suppose this guy is the origin, right? The origin O. Now, what is the angle? The angle is theta, right? So what is theta? Just this axis itself. So that means that at the point here, let's call this point star. This is the origin. This guy is going to be 2. So we can call this point P. Okay, think about the unit circle. Where is 0? 0 is just on the x-axis. So this is in polar coordinates. So angle 0 is just on the polar axis. And the polar axis is what we call the x. The polar axis in polar coordinates is what we call the x-axis in Cartesian coordinates. Okay, so what if we're interested in plotting 2, pi over 2? Again, remember that this first guy is my r, this guy is my angle theta, right? So I can do this. R is 2, right? But you need to take note of the angle. Remember, this guy is 0, this guy is pi over 2. So that means we're going pi over 2. This guy is pi over 2, right? So that means it's just this point. This is just my point P. Okay. So let's look at another one. Okay, so of course, this is the origin, right? So that means the distance from here to here is what is called 2, okay? All right, so let's do another one. Suppose I have 2, pi over 6, okay? Remember, when theta is positive, you go counterclockwise, okay? So that means you're going in this direction, right? So theta is pi over 6. So pi over 6, again, this is 0, this is pi over 2. Pi over 6 lies somewhere here, okay? So that means, so this is like my theta equals pi over 6. Okay. a distance from here to here, we'll call it 2. This point itself, let me just extend this guy a little bit. This point itself, I can just call this guy point P. It's 2, pi over 6. So at this point, I mean, it's still very much basic and easy to make these sketches. Now, we've been talking about the positive guys. So let's look at another example. This example, suppose we have a -1, negative pi over 3. Okay. Now, this is my angle, right, theta? This is my R. Now, in this case, now theta is less than 0. Okay, so whenever your angle, whenever this theta is less than 0, what direction do we go, guys? We'll go clockwise. All right, so pull up this guy. Now, clockwise means I'm traveling this direction. Okay, so if I'm traveling this direction, pi over 3. Oops. Hold up. Traveling that direction, but in this case, pi over 3. So this is my origin. Of course, this guy, suppose this point is what we call, this distance is -1. So that means this point has to be -1, negative pi over 3. Let's call it again point P. So there are infinitely many of these examples we can come up with. But let's look at this interesting one. Now, 0.1, 5 pi over 4. This guy, now remember we said that the angle is not unique. Okay, so this guy, we can also write this guy as 1, negative 3 pi over 4. Or if we want, we can write it as 1, 13 pi over 4. Okay, so these two are basically equivalent. Okay, I hope it makes some sense, guys. Right, so if it does, let's make some progress. Now, if you ask me and say, oh, how did you get this part? I mean, this is my angle, right? Theta equals 5 pi over 4. If you do theta minus 2 pi, you will get this guy. Okay, so let me just write it on the top then. So that's telling you that there's no, this is like theta minus 2 pi. That's telling you that there's no kind of uniqueness. So what do I mean by this? 5 pi over 4 minus 2 pi. And that's how you get this guy. Okay, so there are infinitely many pairs when it comes to Cartesian coordinates. So now let's start with this guy. Let's plot 1, 5 pi over 4. Now, you want to take note, what is theta here? It's positive, right? What direction are we traveling? Counterclockwise. So that means I'm going this way. So this is 0, 5 pi over 2. I mean, pi over 2, this is 3 pi over 2. So 5 pi over 4 is between pi over 2 and 3 pi over 2. 5 pi over 4, no, that's wrong. It's between, this is pi. I'm missing my labels, sorry. This is pi, this is 3 pi over 2. So 5 pi over 4 is in this quadrant, okay? It is in this quadrant. Sorry, I was missing my labels. Okay. So this is 1, 5 pi over 4. But what if I want to sketch 1, negative 3 pi over 4? What is theta in this case? It's negative, right? So in what direction am I traveling? In the clockwise direction. So that means I'm starting from here. Everything starts from this 0, okay? Starting from here, that means I'm traveling in this direction. So you just travel in a way that accounts for that angle, okay? So this point is what we call 1 comma negative 3 pi over 4. So now what about the last guy? Let's sketch this last part, 1 comma 13 pi over 4. Okay, so theta in this case is positive, so you go counterclockwise, right? This is 0, this is pi over 2, this is pi, this is 3 pi over 2. Of course, this is 0, 2 pi. But 13 pi over 4 is like, if you divide it, it's like you have like 3.25, something like that. So what does that mean, guys? It means I start from here. The moment I move a complete cycle to this point, it's just 2 pi, right? So I keep moving until I'm able to generate this 13 pi over 4. This is like 1 comma 13 pi over 4. So this angle itself is 13 pi over 4. So these are, few basic sketches, very basic sketches that we need. So now let's discuss the connection that actually exists between polar and Cartesian coordinates. Okay, so we can actually convert from Cartesian coordinates to polar coordinates, and we can as well convert from polar coordinates to Cartesian coordinates, okay? So let me do something like this. We can go from here to here, and then we can revert back. Okay, so let's see. So we can convert from Cartesian to polar coordinates with, now of course we need the help of a formula, okay? So my r, which is my distance, becomes the square root. Now, if I want to get rid of this square root, what do? I square both sides, right? So you have r squared equals x squared plus y squared. And then you use tan of theta equals y over x. And that means my theta is just the inverse tan of y over x, or what we call the arctan. Okay, so to convert from polar to Cartesian, it will be with a different formula. But to go from Cartesian to polar, this is what we need. Okay, so now let's see. We can convert from polar to Cartesian coordinates with, these are the formulas we do. X equals r cosine of theta, y equals r sine of theta. Now, what does this mean, guys? Can I get cosine theta over here all by itself? The answer is yes. So that means cosine of theta is just x over r. Whatever right here, I can get sine. That means sine of theta is just y over r. You're just making them the subject of the formula. Now, but there's an important thing to take note of, guys, when you do this conversion, okay? When you do this sort of conversion, they really must lie in the same quadrant. I mean, that's the beauty, okay? So let me write that so that you guys can take notes. So notes, you got to ensure that your r, which is the distance, and theta produces a point in the correct quadrant. Okay, so despite the fact that in polar coordinates, remember guys, we said we have infinitely many pairs. Okay, so when we make such conversion, we have to ensure that we only pick the pairs that belong to the correct quadrants. Okay, we only pick the pair that belongs to the correct quadrants. So let's do some example, guys. Example, converts. Now this first example, we're going from polar to Cartesian. From polar to Cartesian coordinates. All right, so solution. Now, when we're doing this conversion, what do we do, guys? We have some formulas. We have x equals r cosine of theta, right? And y equals r sine of theta. I know my theta. This is my angle theta, right? And this is my r. So this is like 2 cosine of 5 pi over 6. And this is just 2 times negative square root of 3 over 2. And guys, this is just negative square root of 3. Same thing is kind of applicable here. This is 2. You have sine of 5 pi over 6. This is 2 times. What is sine of 5 pi over 6? That's exactly 1/2. You got 1. So now in Cartesian coordinates, this guy is going to be, now remember it's x comma y, right? So negative root of 3 comma 1. Okay. Another example. Convert. Now in this case, now we're going from Cartesian to polar, okay? Converts from Cartesian. Okay, so I need you guys to take notes, over here you are. Now we're going to take note of these notes that we had, all right? So solution. Of course, this is my x and this is my y. So what's the formula here? It is r squared equals x squared plus y squared, right? So what is r squared? Square root of this guy squared plus square root of 2 all squared. That means I do have a 2 plus 2, and that gives what, guys? 4. Now, what is the other guy? We had tan of theta equals y over x, right? What is my y in this case? My y is square root of 2, okay, over negative square root of 2. So that means that I'm actually interested in tan of theta equals negative 1. So this means that my theta is going to be the arctan of negative 1. Now, what is the arctan of negative 1, guys? We have negative pi over 4. Now, in this session, guys, we need a unit circle. Okay, so you need the idea of the unit circle. So what other angle is equivalent to negative pi over 4? And that's actually 7 pi over 4, guys. Okay, so you need the unit circle. Now, what does this mean, guys? Remember, in polar coordinates, we have to do r comma theta. So now, what is r? R is, so over here we have r squared equals 4, right? And what does that mean? It means r equals plus or minus 2, okay? Because when you do the square root of 4, plus or minus square root of 4, right? Pretty much I can just say square root of 4, and that's just plus or minus 2. So now, how do I do this? Now, my r is either negative 2 or positive 2. So let me prepare. I have 2. All right. Take a look, guys. Okay, so let's see. Now I have the R's all filled. Now, what about theta? Theta can either be negative pi over 4 or 7 pi over 4. So this is like negative pi over 4. Over here, we could have the same negative, this guy, 7 pi over 4, 7 pi over 4. There should be a negative sign here. Yep. So now, which of these are correct? Now, that's what we need to think about. How do we know what is correct? How do we know the correct one and the incorrect one? Now, how do we do that? We'll go back to this guy. In what quadrant does this guy lie? Okay, so that's the next thing we're going to answer, right? So remember, this is my first quadrant. This is the second guy. This is the third quadrant, and this is the fourth quadrant. Okay, I hope your trigonometry comes back to mind. X is negative, right? Now, in which quadrant is X negative and Y positive? That's the second quadrant. So that means that I have to only select the coordinates that lies in the second quadrant. Okay, so the coordinate that only lies in the second quadrant. This guy is going to be out of it. Okay, this guy's this guy, let me cancel the other one that's not going to be part. This guy's going to be out of it. But these guys are going to be correct. Okay, so you can see that it's this is like a pair. Okay. Right, so we move, guys. Let's discuss the idea of polar curves. Okay. So I'm telling you guys what a polar curve is. Let's start from polar equation. The polar equation can actually be written as in this form. Okay. Or we can write it as this. Okay. All right, it has this guy. So let's see. Now, its graph actually consists of all points, which we call points P, which actually satisfy the given equation. Okay. This guy or this guy. Okay. All right, so example. So we want to graph this guy. Now remember, a polar equation is given by R equals f of theta, right? So I can move this guy, this constant to the other side. I have r equals 2. So this actually describes a circle with radius 2 centered at the origin. Okay, so we have the radius 2 as well as being centered where, guys? At the origin. Okay, so that means you just want to draw a circle. Okay, so this is just a radius 2. R equals 2. Now let's do another example. Now in this case, identify the curve after finding a Cartesian equation for r equals 2 sine of theta plus 2 cosine of theta. Okay. All right. So I want you guys to pay attention to this because it's a little bit different from what we've done. We're actually given that r equals 2 sine of theta plus 2 cosine of theta, right? Where do we start from? Now, keep in mind that the basic thing that we know that r squared equals x squared plus y squared, right? I want to just write all the formulas that we know right now. We know that x is r cosine of theta. We know y is r sine of theta. Now, but if you look at this side, this is just cosine of theta. This is sine of theta. So now how can I introduce r? So that means I have to multiply both sides by r, right? Because I want it to look like this guy. That means I have r squared equals 2r sine of theta plus 2r cosine of theta. Okay, so now this apparently looks like what I need. So this is r sine theta, which is y. R cosine theta is x. So that means my r squared equals 2y plus 2x. Okay, so we use these two formulas already. Now, but this one, we've not touched this guy yet. And this is r squared on this side. So just plug it in, right? S squared plus y squared equals 2y plus 2x. So now, can I actually collect like terms? The answer is yes. S squared minus 2x plus y squared minus 2y equals 0. Okay, now take a look, guys. Now remember, the question says identify the curve after finding the Cartesian coordinates. So pretty much it's like we're on a journey, okay? So it's more like we're on a journey. So now take a look at this, guys. S squared minus 2x, let me put this guy in red, plus 1. Plus you have y squared minus 2y plus 1 equals 2. Now, this is just a trick, guys, because we actually want to get a compact equation. Now, if you think about, if I write 5, 5 is the same thing as, okay, this is still 5. No matter what you add, if you add and subtract the same quantity, you get the same thing. So that's like what we're doing here. We're adding 2 to both sides because I need to find a way to write this guy and this guy as a square of something. Okay, so this is what I mean, guys. The moment you do this guy is x minus 1 all squared plus y minus 1 all squared equals 2. And what kind of equation is this guy? Now, this is where we're identifying, okay? So what kind of equation is this? All right, so I hope I can remind you guys the curve. This is a circle, right? With the radius square root of 2 centered at 1, 1. Remember, the equation is like x minus a all squared plus y minus b all squared equals r squared. Okay, so let me scroll up a little bit and let you guys see this for like a minute. Okay, so let's make some progress. All right. Now, we studied tangent in 10.2. We're just going to reintroduce it. Just to remind you guys. Now, but in this case now, we have given x equals r cosine of theta. I believe we saw this guy. Now, remember, what is a polar curve, or what's a polar equation? A polar equation, let me remind you guys, r equals f of theta. So I want to make this substitution right here. So this guy becomes f of theta cosine of theta. Well, this guy is like, can you just call it, this is the polar curve. Y equals r sine of theta. We'll do the same thing, f of theta sine of theta. Now, when we studied tangent in 10.2, guys, remember we went on from the idea of dy dx, right? And dy dx was dy d theta divided by dx d theta. In 10.2, we used variable t, but right now we're using theta. Okay, these are just variables. So I'm just going to say that. Now, what is the horizontal tangent, guys? I hope you guys remember this from 10.2. We call it HT, horizontal tangent HT. By definition, you set this guy to be 0, and this guy has to be different from 0. I mean, we studied this guy already, so I don't want to go back to explain this. You can see the previous video. What about vertical tangent? Call it VT. Vertical tangents, this guy has to be 0, and this guy on the top has to be different from 0. So I'm not going to do any example on this. I mean, it's the same principle as we learned in 10 points. That we learned already in 10.2. So it's the same principle. The task is to find what values of theta that makes us have either a horizontal tangent or a vertical tangent. Okay. So now let me give you guys another example, an example that looks like the. Okay, so I think let's just go straight up to examples on curve sketching. So first example, example 1. So sketch r equals 1 plus sin theta. Okay, so of course there are a couple of ways to sketch this curve. All right, so I'm going to show you guys. Now, of course, a particular way is to set values for theta, right? You can start calibrating theta, like you have theta pi over 6. You have 0, 0 pi over 6, then you keep increasing in that manner, okay? Or you do 0 pi over 4, pi over 2, and you keep increasing, okay? So, well, let me do it a little different in some sense. So instead of plotting points, we can first sketch 1 plus sine theta in Cartesian coordinates. Okay, so this is just like curve sketching, guys, which is like college algebra. In Cartesian, this is my R and theta. Let's call this guy 1, 2. In Cartesian coordinates, you're going to have this geometry. This is pi over 2. Okay, when theta is pi over 2, what happens? Sine pi over 2 becomes 1. 1 plus 1, you have 2. That's why we have this point here, right? This guy is my pi. Over I have like 3 pi over 2. I have my 2 pi. Okay, what is sine of 2 pi? Sine of 2 pi is 0, right? 1 plus 0 is 1. So that's why you have this guy here. So you're doing 1, 2 pi, 1 comma 2 pi. It's the same way you do the basic curve sketching. Okay, so, but if you want to draw this guy in polar, okay, in polar form, all right, so of course, remember this guy is 0, 2 pi, right? That's this part. This is pi over 2. This is pi, and this is 3 pi over 2. Right? All right, so if you go from this point, guys, to this point, now what happens? This angle is increasing. If you go from here to here, from this guy to this guy, the angle is increasing. From this guy to this guy, the angle is decreasing. We have this behavior, we have that behavior as well. So we have some points or some parts where the angle is increasing, or we are increasing, going in increasing direction. Then we have some point where we're dipping down. We have another point we're going up, we're dipping down, such kind of behavior. Okay, so when you put this together, I have something like this. Now, why do I have this? Now, from 0 to pi over 2, what happens? We're increasing. This guy to this guy, it's increasing. So that means from 0 over here to pi over 2, I'm increasing. But from pi over 2, okay, so but from pi over 2 to 3 pi over 2, from here, okay, so let me write it here, increasing, decreasing, decreasing, right? So from pi over 2 to 3 pi over 2, we're decreasing, okay? So that means this guy is decreasing. Okay, so now let me draw something like this, but let me draw it, let me make it more beautiful. Okay, you see you get it, guys? So you want to locate where you're increasing as well as where you're having some decrease. Okay. Okay, it looks like this. All right, so and then from 3 pi over 2 to 2 pi, you're increasing, and that accounts for this part to this part. Okay, so that's how you think about it. You have to think about the points or the places where you're increasing, and think about other places where it's decreasing. Now let's even look at a more robust one. This has a famous name. It's called the 4-leaf rose. So we want to sketch R equals cosine of 2 theta. Okay. Let me start from, remember, instead of plotting points, I can decide to just you can decide to draw a table and then plot your point. That's okay, okay? So, but I'm just trying to go in a different way. Maybe some of you have not seen before. Now we know that cosine is between -1 and 1, right? All right. Cosine of 0 is 1, so that means we have this guy here. Now, I need to know what increments. From here to here, will it be pi over 6 or pi over 2 or pi over what? So to get the increments, I can set this angle, just set this angle to pi over 2. So that means theta is pi over 4. So this tells me the increments. So that means I'm calibrating in pi over 4. This next guy becomes pi over 2. 3 pi over 4. I get my pi. 5 pi over 4. 3 pi over 2. 7 pi over 4. And 2 pi. Now, when theta is pi over 4, what is cosine of pi over 2? Is 0. So that means this point. When it is pi over 2, you have -1. You go back to 0. You go back to 1. So it's fluctuating between -1 and 1, right? So here we'll come back to 0. Now, how are we getting this, guys? No big deal. When theta is 5 pi over 4, it means you're doing something like cosine of 2 times 5 pi over 4. And that's like cosine of 5 pi over 2. And this is going to be 0. So here, this is going to be -1. This guy is going to be 0. And then finally, we're going back to 1. Cosine of 4 pi is 1. So apparently, it means we're having a situation like this. So you join these guys together. Perfect, guys. Okay, so now I can label each part, call this guy number 1, call this guy. Now you can see the behavior here. You have increasing, decreasing, increasing, decreasing, as the case may be. So call each portion. I want to label each part. Call this guy 5, call this guy my 6, call this guy my 7, call this guy my 8. So now I have to put this guy together, you know, in the polar case. What do I know? I know this is 0,2 pi. I know this is pi over 2. I know this is pi, and I know I have 3 pi over 2 here. Now, let's see. Let's go back here. Now, look at number 1. From between 0 to pi over 4 gives me number 1, right? Between 0 to pi over 4, what do we have? Increasing or decreasing? Okay, that's decreasing, right? Okay, so that means I go from 0. That means I have pi over 4, so let me do something like this. This is pi over 4, right? This guy is 7 pi over 4. This guy is 5 pi over 4. And this guy is 3 pi over 4. Now, what do we call number 1? Number 1 is decreasing, right? And that's between 0 and pi over 4. Decreasing. Take note, guys. So that means you start from a point here. And of course, that's positive. So you're going counterclockwise. So decreasing means that it's going to collapse to the origin. Collapses to the origin. Number 1. It's decreasing, right? So you start from a point here and you collapse it to the origin. Now let's look at number 2. Number 2 is decreasing, right? However, R is negative, okay? So normally, what is number 2? Number 2 is between pi over 4 and pi over 2. This is pi over 4 to pi over 2, right? Usually, I should draw something here, right? But because R is negative, it's going to flip to the opposite side, okay? This is the opposite. It's going to flip over here. Okay, so let me flip it. Now, let me explain again, guys. This is decreasing, right? This is decreasing. From 0 to pi over 4, decreasing, you start from here, you collapse it to 0, okay? But mind you, R is positive. Now, we're moving to number 2, from pi over 2 to, from pi over 4 to pi over 2, decreasing, however, R is negative. Now, when R is negative, it flips to the other side, okay? So R is only positive here, right? So this is this guy to this guy. Normally, I should draw something here, but because it's negative, it flips to the opposite side, okay? So if it flips to the opposite side, we're going to start at a point. Let me just come here. Start at a point here. What happens? I have a behavior like this. Okay. Now let's go to number 3. What happens between pi over 2 and 3 pi over 4? It's increasing. It's increasing, however, R is negative. Okay. So this is pi over 2 to 3 pi over 4. Right? But because it's negative, it flips to the opposite side, and this is the opposite side. So that means you have something like this. Make that better. Okay. Something like this. Oh, so let me label. This is my 2. This is my 3. Now let's go to 4, okay? So in 4, we're going from 3 pi over 4 to pi, okay? So this is increasing, right? 3 pi over 4 to pi. 3 pi over 4 to pi. R is positive, okay? This guy goes to the origin. Okay, I'm going to tell you the arrows later. Okay, so what is number 5? Number 5, we're going from 5 pi over 4 to 3 pi over 2. 5 pi over 4, but R is negative, right? 5 pi over 4, where's my 5 pi over 4? Over here. To 3 pi over 2, between these guys. That means this is the side. Now let's go to number 7. Number 7, we're doing from 3 pi over 2 to 7 pi over 2, right? Crazy. 3 pi over 2. R is 3 pi over 2 to 7 pi over 4. Okay, yes, R is still negative. So this is 3 pi over 2. 7 pi over 4, 2. 1 second, let me just get it right. Oh, yeah, 3 pi over 2 to 7 pi over 4. That's between this guy and this guy, all right? So it's negative, that means something comes up here. Whenever it's negative, guys, it flips to the other side. 7. Now the last part is we're going between 7 pi over 4 and 2 pi. And that's this guy, 7 pi over 4 and 2 pi. It closes up here. Okay, so what are the arrows? This is 8. Let's go to number 2. This arrow points down. This guy will go up. Oh, I think I'm missing one part. Oh, what happened between pi and 5 pi over 4, guys? We missed that, okay? Between pi and 5 pi over 4. Decreasing between pi and 5 pi over 4. This guy. Decreasing collapses to 0. Okay, so this is number 5. Okay, so this is what we call, it's a famous 4-leaved rose. It's called 4-leaved rose. This is a leaf, this is a leaf, this is a leaf, this is a leaf, so it's 4. So theta actually increases from 0 to pi over 4, right? Oh, let's see. Okay, I think we missed that. All right, so yeah. Yeah, we have increase, yeah. Then we have, this is just like a caveat of what we've done so far, okay? Okay, this decreases from 1 to 0. And then now, if you talk about this interval, R goes from 0 to -1. Okay. So better still, guys, even to get the angle, it might be okay to use sometimes you can use R too. Okay, so over here R is 0, R is -1. It tells you it's decreasing. Over here R is -1, you're going to 1. It still tells you increase. Okay, I hope the whole of this, all of this makes sense. And I'll see you in the next session, guys.